In this video, we are going to discuss percentiles of ungrouped data. And for our objectives, we have number 1, illustrate percentiles. Number 2, calculate a specified percentile of a set of data. Number 3, interpret a percentile. And number 4, solve problems involving percentiles. So let's discuss percentiles. There are 99 percentiles which partition the data into 100 groups with about 1% of each group's score. Percentiles are the values that divide a set of ranked data into 100 equal parts. So these values are denoted by P sub 1, P sub 2, P sub 3, up to P sub 99. So for example, the values of P sub 50 or the median means 50% of the data have lower values than P sub 50. So these percentiles are computed in the same way that the quartiles and the deciles are calculated. So let us have this diagram. This first quartile here, or the Q sub 1, is just the 25th percentile, or the P sub 25. The Q sub 2 here, or the median, is just the P sub 50, or the median of the percentile. The third quartile is just the P sub 75 of the percentile. Likewise, the D sub 1, or the first decile, is the 10th percentile. The second decile is the 20th percentile. Third decile is the 30th percentile. Fourth decile is the 40th percentile. Fifth decile is the 50th percentile, or the median. Okay. The D sub 6 is the P sub 60. The D sub 7 is the P sub 70. D sub 8 is the 80th percentile. D sub 9 is the 90th percentile. So what are the steps in finding the percentiles of ungrouped data using linear interpolation? That is, first, arrange the scores in ascending order. Next, locate the position of the score in the distribution. So here we have the formula. So the position of the percentile is equal to Kn over 100 plus 1/2. So here, K is equal to 1 if you are looking for the first percentile, 2 if you are looking for the second percentile, 97 if you are looking for the 97th percentile, 99 if you are looking for the 99th percentile. And N here is equal to the number of scores. And finally, the last step is interpolate the value. So now let us have an example. Find the 73rd percentile, or the P sub 73 of the given data: 22, 20, 27, 14, 12, 9, 27, 4, 13, 28, 17, 37, 16, 7, 11, and 13. So how do we find the 73rd percentile? So to find the P sub 73, our first step is to arrange the scores in ascending order. So the scores here is already in ascending order. That is from the problem. Next, locate the position of the score in the distribution. So here, the formula for the position of the percentile is equal to Kn over 100 plus 1/2. So our K here is equal to 73 since we are looking for the 73rd percentile, or P sub 73. So that is, P sub 73 is equal to 73 times N over 100 plus 1/2. So here our n is 16 since the number of scores here is 16. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is 73 times 16 over 100 plus 1 half. That is 12.18. For the last step, interpolate the value. So these are the steps of interpolation. So since using the formula in finding the position of the 73rd percentile, we obtained 12.8. So 12.8 is in between 12 and 13. So here we are going to subtract the 12th data from the 13th data. So the 12th data is 22, the 13th data is 27. So that is 27 minus 22 is equal to 5. We are going to multiply this 5 by the decimal part obtained in the step 2. So we obtained there 12.18. So that is 5 times 0.18 is equal to 0.9. And next, we are going to add the result in step B. This 0.9 to the 12th data or to the smaller value. So that is 22. So that's 22 plus 0.9 is equal to 22.9. So therefore, our P sub 73 is equal to 22.9. So how do we interpret this? So that is 73% of the students spent at most 22.9 hours answering their module in 1 week, or 23% of the students spent at least 22.9 hours in answering their module in 1 week. So in this lesson about percentile of ungrouped data, you are going to answer activity 6B.5, 10 or 100.